All right, this video is to review the law of sines, which we discovered in a previous activity. There are examples that go with this lesson. However, those will be in a separate video. So the learning outcome from the lesson this presentation comes from is by the end of today's lesson, I'll be able to solve problems using the law of sines. Again, this video is just going to review what the law of sines is. The examples from this lesson will be, again, in a separate video. The law of sines, as we've previously seen, is that if we have a triangle, and that could be a right triangle or not a right triangle, where capital A, B, and C are the angles, and lowercase a, B, and C are the sides opposite of those angles. That is, for angle A, the side opposite or across from it will be side A. From angle B, the side across from it will be side B. And from angle C, the side across from it will be side C. If we have a triangle labeled in that fashion, then the sine of a particular angle divided by the side across from it forms a ratio that is equivalent to that same ratio for any angle and side across from it pair. So as you see here at the bottom of the slide, the sine of angle A divided by side A is equal to the sine of angle B divided by side B is equal to sine of angle C divided by side C. If you look this law of sines up online, you may see these ratios inverted, where the side is in the numerator and the sine of the angles in the denominator. It's still the same thing, because as we'll see in the coming slides, we're going to cross multiply anyway, and we'll end up with the same type of equation. So if I have a problem and that I think I'm going to use the law of sines for, what I'm going to do is I'm going to draw and label a triangle that models the problem if one's not provided. Then I'm going to select two of the ratios from the law of sines and write a proportion. Once I have this proportion, I'll cross multiply and solve for wherever the variable is. Now, notice in number 2, it said I'll select two of the ratios. The law of sines includes 3 ratios, but we will never work with all 3 at one time. We're only ever going to pick 2. So when I draw my triangle and I label it, if I happen to have, say, angles A and C, I would pick the ratio here involving angle A and the ratio involving angle C. I would set those equal to one another, forming a proportion, cross multiply, and solve. Now with this, because the law of sines essentially requires us using 2 of the 3 ratios, we will need 2 angles and 2 side lengths that are across from those angles. Well, for this to work, we have to know 3 of those 4 pieces of information and solve for the 4th one. So we either need to know 2 angle measures and 1 side length that's opposite one of those angle measures. It's important that it's opposite of it or across from it. Or we need to know 2 side lengths and 1 angle measure opposite one of the sides. Again, it's important that it's opposite or across from it. Otherwise, the law of sines will not work. So what this sets up is this sets up 4 types or cases, if you will, of triangles in which the law of sines will work. We're going to find later that there are some triangles where the law of sines will not work because we don't have the necessary information. And we'll see what to do in a later lesson for that. So these 4 types or cases that we can use the law of sines to solve. The first one is angle side angle. That is, the side that we have is between the 2 angles that we know. And in this case, I wouldn't know the angle across from it, but since I know that all of the angles in a triangle add up to 180 degrees, I can easily find the angle that is across from that given side. We also have side angle side. So in this case, the angle I have is formed by the two sides that I know. We have angle side. That is, I have two angles, and the side that I know is extending from one of those two angles. So it's not the side in between the two angles, as in number one, but it's outside of it. Again, we could find the third angle by using the fact that the sum of the angles in a triangle is 180 degrees. And then the fourth one, which we will not deal with in Math 4, is when I have two of the sides and an angle that's not, in one of the angles that's not formed by the two sides. The reason we're not going to tackle this in Math 4 is this is what is called the ambiguous case. And in Math 4, the standards simply say that we are supposed to solve problems in a context. And I'm going to show you why we can't do that with something as far with the ambiguous case. So this is a GeoGebra model of the situation where we have the ambiguous case. So notice we have side A, we have side B, and we have angle A. And angle A happens to be the angle that is not formed by the two sides. So if we go back and look at our cases here, we'll see that when we have two sides, the only way the law of sines will work for what we're doing is if it's the angle formed by the two sides, like right here in case 2. So with this, you can see already that with the information given, if side B was 9 units, side A was 3 units, and angle A was 30 degrees, it doesn't form a triangle. Right? This does not form a triangle. So we can see right now you could end up with measurements in this case that don't even create a triangle. And therefore, it wouldn't solve a problem. Another possibility, though, is if we extend the length of side A, we could have two potential triangles. We could have this triangle here, ACB1, or we could have the triangle ACB2. So as we saw in the first example, it is possible for us to have no triangles. Now we can see that the ambiguous case could give us two triangles. And if we were to form, let's see if I can make it do this. If I was to form a right triangle, it is possible to get exactly one triangle with the ambiguous case. I think it's going to be very difficult to do, though. It is possible, and when you get one triangle, usually it's a right triangle, I believe. All right, so there is the potential for having one triangle. That's about the closest I can get it with the stuff provided here. But anyway, you should be able to see the concept that there is a possibility of getting exactly one triangle. It would end up being a right triangle, or that we could have no triangle, or that we could have possibly two triangles. And that's why we will not be using the ambiguous case in Math 4. In a trigonometry class or pre-calculus, you would solve for all possible triangles, not in an actual applied problem, but there would be cases where you would solve to say, well, these are the two possible, or there is no possible triangles with the information given. You would learn how to do that. All right, well, this concludes this video. Again, there will be a follow-up video with the examples.